Hi, good morning, everyone. My name is LJV Miranda, and I will be presenting our paper, Developing a Name Entity Recognition Dataset for Tagalog. The main reason why we undertook this project is because there is still no general purpose NER dataset for the language. As we all know, Tagalog is a low resource language and every bit of corpora counts. Of course, there are many alternatives to build NER models for Tagalog. We have Lorelei, which contains a Tagalog language pack from LDC or the Linguistic Data Consortium. We have WikiAn, a silver standard corpora based on Wikipedia. And we also have the storytelling dataset. It's gold standard, it's sourced from short story books, but it contains a very domain specific tag set. And as we have seen, and as we will see later on, they lack the necessary properties for building general purpose NER. So in this case, Lorelei is not publicly accessible. It is behind a paywall. WikiAn, because of its silver standard nature, upon inspection, realized that it doesn't have high quality annotations. And also, the text examples are quite fragmented and disjointed. And finally, again, storytelling has a very domain specific tag set. So we believe that there is still a huge gap to fill for Tagalog NLP resources. We want to start with NER because it has a lot of industry and practical use cases, and it can be general purpose enough, unlike, say, text classification, to invite further study. And so we developed TL Unified NER, a high quality NER dataset. It is actually based on the TL Unified dataset, another high quality pre training corpus that includes news reports as one of its domain. It is publicly accessible. You can access it on Hugging Face datasets or in GitHub. It contains high quality annotations, as we will see later, with a good inter-annotator agreement and a rigorous annotation process. The texts themselves contain coherent and complete sentences, thanks for the pre-training corpus. And in our opinion, this increases its usability for real-world applications. And finally, it has a more general tag set for building general purpose NER systems. We are actually trying to pattern this corpus to the Connell dataset to create stronger baselines for Tagalog. So you can access the dataset on Hugging Face, and here you can see the dataset statistics. We hope that TL Unified NER will fill the resource gap present in Tagalog language for structured prediction tasks. So I want to talk a bit about how we develop the corpora. We develop it in an iterative and rigorous annotation process. So instead of annotating everything in one go, we batched the examples and annotated them for a set number of annotation rounds. This process lasted for 4 to 5 months with 7 rounds in total. We tried to stagger these annotation rounds as much as possible to minimize fatigue and human error from annotators. In software development, we usually call these rounds as sprints. Just decided to call it differently to remove the connotation of urgency, as in sprinting. So for each annotation round, there are 3 steps. The first one is, of course, annotating. Here, we annotate a batch of examples. For me, I hired 2 more annotators, including myself, so bringing a total of 3 annotators for the project. Of course, all of us are native Tagalog speakers, and we're using a tool called Prodigy as our annotation interface for labeling. Then, at the end of each round, we evaluate the annotated batch. Because I'm also an annotator, there's a chance of bias. So what we did is we conducted a lot of retrospective meetings at the end of each round. Here, we discussed disagreements in annotations, and usually these disagreements were rooted from, let's say, vagueness or misinterpretation of annotation guidelines. In addition, we also tracked the inter-annotator agreement and a training curve to determine whether we need more training examples. As a rule of thumb, if the accuracy improves within the last 25% of annotations, then training with more examples will likely result in better accuracy. And then finally, we updated the annotation guidelines. So we have a moving, living document that contains our guidelines. And these guidelines underwent several revisions. This includes more examples, clarifying vague phrasing, and much, much more. So I want to talk a bit about how we computed our inter-annotator measurements. For us, we think that kappa isn't really the best measure for an ER because it requires a certain number of negative cases, and usually this is not known for the name entity task. The usual solution that we see in literature is to compute kappa on all tokens. So that's the first row you see on the table. But annotators, they label spans instead of individual tokens, creating a bit of a word alignment problem. Another issue is that the unannotated tokens, the O tag in IOB, usually outnumber that of actual entities. So in some ways, you're actually getting a lot of points, and this kind of overestimates the kappa score. So our second alternative is to first compute kappa for tokens where at least one annotator has made an annotation, and that's the second row on the table. But this one has the reverse problem, where it underestimates the IAA. I mean, you also want to consider the O tags, not ignore them completely. So in literature, we found that the recommended IAA measure is to find overlap simply by using the F1 score, using one annotation set as reference and the other as predictions. And that's what we did for our third measurement, the third row on the table. Personally, I think that F1 score is a good measure because it balances the false positives of the first kappa and the false negatives of the second, similar to balancing a high precision and a high recall measurement. But for the sake of completeness, we're reporting all three computations. We also track the growth of IAA for each annotation round just to see that we're improving in some way. Given that, our IAA metrics still show our annotations are of high quality. So given these annotations, we ran some benchmarks and we want to check if the dataset itself is learnable. We tested on 5 model configurations in a supervised learning setting. The main difference between them is the type of word embeddings they employ in the second column and their language coverage, which would be in the third column. Our baseline approach is simply training a transition-based parser from Spacey. We are not using any additional information from static vectors or context-sensitive word embeddings. Then we went through common techniques for NER. We started with using fast text embeddings for Tagalog, then a monolingual Roberta model, and then followed by the usual multilingual transformers, that is XLM Roberta and multilingual BERT. And then you can see the results on the right chart. So there's nothing surprising from these numbers. Of course, the monolingual Roberta is the most performant. But for us, the most important takeaway here is that the models can learn from our annotations. In a way, they actually make sense. We didn't stop there. We delve a bit deeper and examine if there are any humps in our baseline model from the dataset. The first thing we noticed from this confusion matrix is that there is a performance drop between organization and location entities. Our hunch is that the baseline model trips over semantic differences, especially if the entities are lexically similar. For example, Malacanang, akin to the White House in the US, can be an organization or location. The entity GMA can be an organization, can be a location, and even a person. So we look into ways on how we can share semantic information to our embeddings. One approach is by co-training a dependency parser and a parts of speech tagger with the NER model and then sharing their weights. We don't explicitly share the information, but we're hoping that this parameter sharing process helps. The second approach is by pre-training using a closed task and then training the NER model on top of it. The table below shows the relative error decreased on these entity labels, so the higher the better. For us, the key takeaway here is that for users who want to train models on top of TL Unified NER, we stress that using context-sensitive embeddings should work. We also compared how TL Unified NER fares against WikiAnn. We compared against WikiAnn because it has the most similar tag set, and it's the nearest alternative to our corpus. Although WikiAnn has high coverage, it has a lot of annotation errors upon inspection. In addition, most of its examples, the text inside it, contains fragmented and incoherent sentences. Oftentimes, they're stemming from bad or even very literal translations. We can perhaps attribute this to its silver standard nature. Nevertheless, we still want to empirically determine if our gold standard annotations is a better resource for training models. So here we set up an experiment where we trained on WikiAnn and tested it on TL Unified. Then we did this vice versa. For the latter, we re-annotated WikiAnn test set using our annotation guidelines so that we can evaluate a model onto it. The chart below shows the performance gap between the two sources. Here it is apparent that models trained on TL Unified are much more performant than that with WikiAnn. In addition, we are also curious as to how much is the delta or the difference between the silver standard WikiAnn annotations and our re-annotated test set. Here, we simply measure the F1 score similar to the overlaps earlier, and you can see the values in the table below. Organizations definitely underperform, not only because they were underrepresented in the original labels, but also because they were annotated incorrectly. Given this, we believe that TL Unified sets the standard for Tagalog NER. Finally, we also tested on large language models. LLMs are incidentally multilingual, primarily due to the texts they were trained upon. In addition, there are many anecdotes on how these language models can seemingly generate coherent Tagalog text. And so we're interested in how they fare on structured prediction tasks. In this setup, we wrote a zero-shot prompt. This prompt includes a task description, a format instruction, and a brief explanation of the labels. We then sent this prompt on a variety of open source and commercial large language models. And you will see the results here. The bars on red are the supervised learning equivalents from the earlier results. Perhaps the key takeaway here is that in terms of reliability, supervised models trained directly from TL Unified still outperform our zero-shot methods. To be honest, I can only give hunches as to why. First, perhaps text generation is not equal to structured prediction performance. Doesn't mean it can generate text well, then it follows that it understands it. Another reason might be that there is no Tagalog in their pre-training corpora. And finally, perhaps our prompt is not optimized. However, I can speak about reliability. We think that supervised training using the TL Unified corpora is still performant and predictable. I also don't want to discount large language models. Personally, I'm interested in exploring how we can use LLMs to bootstrap annotations to expand our corpora or to build new datasets for new tasks. Given this, we hope that TL Unified NER is a step forward to more Tagalog NLP resources, and we encourage researchers to build on top of it. We've shown that it is of high quality. We decided on a more focused approach in getting the annotations with a decent inter-annotator agreement score. We've shown that it is learnable. There is decent performance when using a baseline transition-based parser and a transformer-based method. In addition, we also recommend focusing on context-sensitive embeddings to help disambiguate semantic differences in the text. Finally, we've shown that it is novel. Compared to the current state-of-the-art, which is WikiAnn, models trained on top of TL Unified is far superior. In the future, we plan to expand the tag set of TL Unified so that it follows the ACE 2004-2005 guidelines. I'm definitely interested in adding more fine-grained tasks that includes a bit of hierarchy and perhaps overlaps in the tag sets. Again, thank you for listening to this presentation. If you have any questions, feel free to contact me in my email. You can download the dataset on Hugging Face using the QR code on this slide. Thank you so much.